Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over how to carry out operations on polynomials, namely how to add, subtract, and multiply. Don't forget there are practice problems at the end of this presentation for you to check out once you're done. So make sure you watch the entire presentation, try out the practice problems to demonstrate mastery of the contents of this tutorial. Alright, so the instructions for these problems are for us to simplify the given expressions. Okay, so for question number 1, let's say we have the sum of two polynomials, a quartic with 4 terms, x to the third plus 1 minus 4x plus 3x to the fourth added to a quartic trinomial 4x minus x to the fourth plus 5x to the third. Alright, so we can clearly see that this is an addition operation. We're going to be using the vertical methods to carry out the addition process here. Okay, so let's go ahead and rewrite both addends in standard form in descending order of degrees. So for the first one, the highest degree term is the quartic term, 3x to the fourth, the fourth degree term, and then the next is the cubic term, or the third degree term, x to the third, linear term minus 4x plus 1. Okay, so when you write it in descending order of degree, that's the standard form. Same with the second addend polynomial expression. First term is a quartic, negative x to the fourth, and then plus the cubic term, third degree term, 5x to the third, plus the linear term 4x. Okay, so now what we're going to do is write down the first of the two polynomials we're adding, and we're going to make sure that all the degree terms are accounted for. If we're missing any, we just use a placeholder. Okay, so starting from the highest, 3x to the fourth, and next is x to the third power term, x to the third, and then we need the quadratic term or the second degree term. We have none, so we're just going to put a placeholder just in case, plus 0x squared. Okay, and then we have a linear term, negative 4x, and then a constant plus 1. Okay, so now what we're going to do is we're going to place the terms of the second polynomial expression in such a way that like degree terms line up vertically. It's just like when you're adding digits, you're adding numbers, you want to line up the place value of the digits so that you're adding appropriate equivalent place values. Okay, same principle applies here. Like terms are terms with the same degree. So negative x to the fourth goes underneath the quartic term right here. So negative x to the fourth. And then 5x to the third goes underneath this column right here with the cubic term. So plus 5x to the third. We don't have any quadratic term. And then we have plus 4x goes underneath here. Plus 4x. And that's it. Okay, so notice how like degree terms are oriented vertically. So let's just highlight it for you to see. So you see here, this is the fourth degree term, right? Highlight organized together, and then the third degree terms, and then the linear terms right there. Okay, so that's how you stack it up so that you make sure you're adding like terms. So all you just do is basically combine coefficients. Alright, so this has the invisible coefficient of 1. The operation here is addition. So 3 minus 1 is 2. And then bring down the variable term, x to the fourth. Here you have 1x to the third plus 5x to the third. Add the coefficients. 6, bring down the variable term. Alright, and then plus 0x squared. And then plus minus 4x plus 4x. Minus 4 plus 4 is 0. So it doesn't really matter the sign that you put. And then 1 plus 0 right here is plus 1. Okay, so the terms with a 0 coefficient do not need to be written in the final solution. So our answer is going to be 2x to the fourth plus 6x to the third plus 1. A quartic trinomial. That's the final answer for question number 1. All right, so now let's take a look at a situation where we are to subtract. So for number 2, let's say we have 5x to the 4th plus 2x minus 1 minus 2x squared. So we have this quartic polynomial with 4 terms, and we're going to subtract a quartic trinomial from it, 2x squared minus 3x to the 4th plus 4x. All right, so let's do the subtraction of 2 polynomials procedure. So write the first one in standard form, descending over order of degrees, so that will give us the quartic term first, the 4th degree term. And then what's next? The quadratic term, negative 2x squared, linear term, and then a constant, okay, in standard form. And then this second one right here, quartic term is the highest degree. The 4th term comes first, the quadratic term, and then the linear term for x. Okay, now when you're subtracting polynomials, what you do is you add the opposite. All right, so you distribute this minus to all these terms right here. All right, and then the signs are going to change. So this minus is going to become a plus, and then this will all become the opposite. So you add the opposite, so this will become a plus, this will be a minus, and that will be a minus. Okay, so when we distribute that minus, we're going to have 5x to the 4th. This one remains unchanged because it does not have a negative in front of it. And then over here, this minus is distributed, so we're going to add the opposite. So distribute the minus to this term, it becomes positive 3x to the 4th. When you distribute the minus to the quadratic term, it becomes minus 2x squared. And when you distribute minus to the linear term, minus 4x. Okay? Now we're going to, so it's now basically like an addition problem like we have on the left side. So let's rewrite the first one, and then put in placeholders for missing the degree term, 5x to the 4th. We're missing the cubic term, so 0x to the 3rd minus 2x squared plus 2x minus 1. Okay? And then put the other one in the bottom, making sure that identical terms or like degree terms are aligned vertically. So we're going to have 3x to the 4th in the quartic column, and then negative 2x squared in the quadratic column right here, and then minus 4x in the linear column underneath 2x. Okay, so we're adding the opposites, so we're just going to add as an addition operation now since we already distributed the negative sign. So just add downwards coefficients and drop variables. 5 plus 3 is 8, 8x to the 4th plus 0x to the 3rd. These two signs are the same. Add and keep the sign. Minus 4x squared. Combine these two, minus 2x minus 1. And there you have it. Okay, so the final answer, the terms with a 0 coefficient are dropped off. So we're going to have 8x to the 4th minus 4x squared minus 2x minus 1 as our final answer. All right, let's go ahead and box that. Okay, let's move on to the last example, which is to find the product. All right, so for number 3, what if we are to multiply the following? We have 2 factors. So you have a quadratic trinomial, 3x squared minus 3x minus 3. You want to multiply that by a binomial x plus 3. Okay, so let's do it. We're going to be using the box method to carry out this multiplication operation. So let's create our box array of cells using the number of terms. So the trinomial, the quadratic trinomial has 3 terms. So it's going to be a 3 by 2. Okay, so that will be what we have. So basically it's kind of backwards. We're going to have 2 by 3 if you want to be specific. We're going to have 3 columns and 2 rows. So let's put the bigger polynomial on top. It doesn't really matter how you do it. So 3x squared minus 3x minus 3. Okay, and then that tells us we're going to have 3 columns here. So let's go ahead and start building our box that we're going to use for our box multiplication. So we have that. All right, so we're going to have on the right side there are 2 terms. All right, so we're going to have x row in the positive 3 row. All right, so hopefully you can visualize what the box is going to look like. All right, it's going to be a box with 6 cells in it. All right, it's kind of like a multiplication matrix or grid right here. Okay, there you have it. So now what we're going to do is just simply multiply terms row by column, and then row and column terms, and then put the product in the intersection of the row and column. All right, so for the first one, we're going to multiply, let's multiply x by all these 3 on the top. So we're going to have x multiplied by 3x squared. What is x times 3x squared? For this one, remember the property of exponent, the product property of exponents, right? If you multiply 2 exponents of the same base, you add the powers. All right? If they have coefficients, you multiply the coefficients and add the powers. All right, so let's say you had ax to the a times b x to the b. Multiply the coefficients, a times b, right? And then you bring the variable and add the powers, a plus b. Same situation here. So for this one, we're going to have just 1 times 3, which is 3, x to the, there's a 1 here, 1 plus 2, 3. Okay? So here is going to be 3x to the third. Let's go with the multiplication of x by the next term, the linear term. So 1x times negative 3x. All right, let's put powers here so we know what we're doing. 1 times negative 3 is negative 3. X to the 1 times x to the 1, you add the powers, x to the 1 plus 1, x squared. So this is negative 3x squared, the product of these 2 terms. And then lastly, for the x row, we are going to have 1x multiplied by negative 3. Okay, so just multiply the numbers, that'll be negative 3, and bring the variable over, x to the 1 is just negative 3x. All right, so this negative 3 over here has an x to the 0 attached to it, but you don't have to write it. Okay, but when you add 0 to this 1, it's just going to be 1. It doesn't change. Next row, we're going to multiply 3 by all these 3 terms. 3 times the first term, 3 times 3x squared. Just multiply the numbers, 3 times 3, 9x squared. So 9x squared in the first cell. And then 3 times negative 3x. All right, that'll be negative 9x. Right here. And then lastly, 3 times negative 3, which is negative 9. Okay, so we've completely filled out our multiplication chart or matrix. All we just have to do now is combine like terms and we're done. All right, so let's start with the highest degree term, 3x to the third, the cubic term. There's nothing to be combined with, so it's just going to be 3x to the third. All right, let's move on to the second degree terms or the quadratic terms. See this diagonal right here? These 2 terms are like terms, so we're going to combine them. All right, you just combine the coefficients, add or subtract, and then you bring down the variables. So 9 minus 3 is 6, so we have plus 6x squared. And then next we have minus 3x minus 9x. Combine these 2. Minus 3x minus 9x is going to be, same sign, so you add and keep the sign, so minus 12x. And then the constant has nothing to be added to, so we just bring that down. And ladies and gentlemen, there goes your answer for question number 3. You can also do this by following or using the vertical multiplication procedure, but I find this to be the safest way to multiply polynomials with a lot of terms, namely where the You have a polynomial that has more than 2 terms be multiplied by another one with 2 or more terms. Alrighty, so here are some practice problems for you to try out. So go ahead and pause the video presentation at this time, and we'd like you to simplify the following. When you are done, click on the playback button, and we're going to reveal what the correct answers are. All right, welcome back. Here are the answers to questions 1 to 4. So how well did you do? If you got them all right, go ahead and destroy that like button for us. If you got anyone wrong, let us know in the comment section below what you got wrong, so that we'll be more than glad to provide you with assistance. Thanks again for taking the time to watch this presentation. Don't forget to help support our channel with your likes, subscriptions, and comments. Tons of support resources can be found at mathgotserved.com. Do check it out. Thanks again for watching. We'll see you in the next video. Goodbye.